All right, and welcome to the video for lesson number 6, GCF and the difference of two squares. Some factoring methods that you learned way back when in Algebra 1. Obviously, in Algebra 2, we're taking things to a little bit of a higher level, so some of the questions are a little bit more challenging, but the basic idea of the factoring is the same. I know this lesson is a little bit longer than some of the others, so we didn't get a chance to finish probably in your class. So I figured I'd put number 8 here from the notes, just in case we didn't get to it. If we did get to it, you could just fast forward to the homework, which will come up in a minute or two here. So for number 8, first thing I notice is there's a GCF here and here, right? So those two expressions are common. So I'm going to factor them out. So I'm going to take out x to the 4th minus y to the 4th. Well, if I do that, that's going to leave me with a squared minus 4. Now, that is factored, but not completely. Remember in class we said that word means that you probably have to factor more than one time. So let's take a look at what we can still factor here. So x to the 4th minus y to the 4th, well, we have subtraction, and we have two perfect squares, so I can use difference of two squares here. So I'm going to do x squared plus y squared, and I'm going to do x squared minus y squared. Same thing with the second term. I have a squared minus 4. Well, that's also difference of two squares, a plus 2, a minus 2. I'm hoping that one was a little bit easier to see. Then I have to ask myself that same question again. Can I factor anything? So the first term, the answer is no, because it's plus. We proved that in class today. The second term here, x squared minus y squared, that can actually be factored. So if I take that expression, I can go through and make that x plus y, x minus y. The last two expressions, nothing can change about them, so then we're done. Again, not like it's a difficult question, but there's a lot of stuff to look for. That's the hard part here. All right, so let's jump to the homework. Notice for the homework, it just says to factor. It's not going to tell you what type of factoring to use. That's something that you have to be able to do yourself. So you have to be able to sit there and say, I'm factoring by blank method. So looking at that first one, I see a difference. I see two terms. I'm going to guess it's difference of two squares, which it is. So I'm going to make this x squared plus 9 and x squared minus 9. Again, completely usually means more than one step. So I'm always going to keep asking, can I still factor? First expression, no. Second expression, yes. So x squared plus 9 is good. X plus 3, x minus 3. So there we're done. There's nothing left to do. Let's look at the second one. So I have 9k squared minus 49. So we can take a little difference of two squares again here. So I have 3k plus 7 and 3k minus 7. For that, even though it does say factor completely, there's nothing left to do there, so we are finished. Let's look at number 2. Factor over the integers for the expression completely. Over the integers is just a fancy way of saying that we're plugging in whole numbers for t, but we're not doing any of that. It's just asking us to factor. So first thing I want to do here is look at our numbers, 12 and 75, and then I'm going to look at my t's as well. So I see that 12 and 75 have a common factor there of 3. So if I take out a 3 by kind of like undistributing or using the GCF, and our variables always have a GCF of whatever the smaller variable is. So if I look at t to the 8th and t to the 4th, well, t to the 4th is my common term there. So if I divide out, I'm left with 4 t to the 4th minus 25. Again, it says that word completely, so I got to look and see if I can still factor, and I actually can. 4 and 25 are both perfect squares, so I'm going to look to try and do difference of two squares here. So that's going to become t to the 2nd plus 5 and 2t to the 2nd minus 5. That is a t. All right. Nothing left to do because 5 is not a perfect square, nor is 2. So even though this is subtraction in that second term there, we can't actually factor it. So we're done. Let's look at 3. 3 is really what we want to be able to work towards this year, being able to factor out expressions instead of single terms or monomials. So looking at that first setup there, we see a common factor of x plus 5. I then have x squared minus 9. Now, if you were to distribute in, and that's what you've been doing for so many years, so it's hard to not do it on like a quiz or a test or something like that. If you were to distribute those terms back in that 4x squared and that 9, you're going to get a trinomial or even possibly a 4-term polynomial that's going to be really hard to factor. So this makes it easier. All right, so if you don't see that, you might get to a problem that you can't factor because you don't even know how to factor it. Okay, so if we leave that here, we then can use difference of 2 squares because it does say completely, so we want to keep factoring as much as possible, and we're done. All right, second one, again, we see a common factor here, so we have 6x minus 5y, and we're left with x squared minus 4y squared. The x squared minus 4y squared can still be factored, so I have 6x minus 5y, x plus 2y, x minus 2y. So again, seeing that same structure as just a regular GCF question is important here. Number 4 asks us to explain why x squared plus 1 cannot be factored over the real numbers as x plus 1, x minus 1. So essentially, this is just a fancy way of saying prove that x squared plus 1 is not equal to x plus 1, x minus 1. So in the proving identities lesson, we never prove things weren't equal to each other, but it's the same idea. We're just going to work on one side of the equation and prove that it's not the same as the other instead of proving that it is the same as the other. So there's really no difference here. So I don't know anything I can do with x squared plus 1, so I'm going to work on the right-hand side of this equation. So I'm going to say x squared plus 1 is not equal to, and since I've been doing a lot of tabular in class, I'm just going to do some distributing here. I think it's a little bit easier for these 2-term polynomial conjugate pieces anyway. And we can kind of go through here and just say this becomes x squared plus x minus 1. If you're really good, you notice those were conjugates from class, and you already knew that it was going to become x squared minus 1. But if you didn't, totally fine. I promise we'll get you there. So then we see that these two things are not the same expression. One is addition, one is subtraction. So I've just proven that. Now, here's the trick. This word asks you to explain your answer. So if this was on the Regents exam and all of this work is correct, it's exactly what we want, you didn't actually say anything to me in words, you don't get full credit. So what I would have to say at this point is when x plus 1 times x minus 1 is multiplied, it is not equal to x squared plus 1. Essentially, I'm restating what I did mathematically in words. It doesn't have to be word for word what I wrote there. You can write your own sentence that fits what you want. I hope this video helps. I hope you're remembering a lot of this from Algebra 1. Remember, next week I will be after school for extra help. I don't know if I mentioned it in class or not, but I'm going to stay after on Tuesday this week instead of Wednesday, and we can go from there.